So using our strain energy concept, we need to get the deflection at the free end. So this is the concept of bending. Hence, strain energy due to bending is to be observed. So if you consider this is the entire portion, take B as the origin. If you cut a section at a distance of x from B, take the free body diagram towards right side. This is your section XX. The load of W is acting. This point is B. This distance is X. Now tell me what is this moment at section XX? Is the moment at section XX? Can anyone of you tell me? So I am taking the moment about this section, which is nothing but W into X. The moment is nothing but W into deflect like this. So when it is deflecting in the downward direction, the curvature it is giving hogging moment. This is giving hogging moment. So hogging moment is negative, hence minus W into X. Moment is W into X and hogging is considered as it is giving hogging moment. Sagging will be considered positive, hogging will be considered negative. Now, we know that the strain energy U is equal to integration of mx x integration of 0 to L
pi into x cubed by 3. And the limits are 0 to L.
So the total strain energy is W square L cube by 6 EI. So after getting the strain energy, our intention is to get the deflection. So delta is nothing but 2U by W. So it is nothing but this W and this will be cancelled. This is 3 times. Which is W L cube by 3EI. So deflection but W L cube by 3EI. From your basic strength of materials, either by method of moment area method or conjugate beam method, we have done this, that is WLQ by 3EI. Is the deflection for the cantilever beam at the free end. we considered strain energy, and wherever the point load is applied under this point load, we calculated what is the deflection. What is the deflection? Now we will solve one or two problems in this class. In the next class, I will explain the next method, which is unit load method. What is the problem for practice? Determine the vertical deflection at Z press loaded as shown in figure. All the members have same cross-sectional area of 1500 square mm, and E is equal to 200 GPa. This is NDA, this is NDE.
So we have to
Calculate what
calculate what
is
is
the
the
force
force
in
in
the
numbers.
Here 10 kilometers load is acting in the upward direction. So the first calculate what is the force in the members. Our idea is can you hear me?
Yes, sir.
So here, so to get the deflection at C, it is 2U by W. Here, W is nothing but 30 kilometers. So U is nothing but sigma E square into L by 2AE. Now this P is to be calculated corresponding to the forces of 30 kilonewton as well as 10 kilonewtons. Try to solve this one, all of you. Just see here, the idea is to get the forces in each member. What is the force in each members? Using method of joints, go joint by joint, and at each joint calculate what is the force in the members. Then do this tabular form here. Area of the cross section is mentioned as 1500 square mm and E is 200 GPa. So you will get P value and the length of the member. This is 2 meters. This is 1.5. Can anyone of you tell me what is the value? Square root of 2 square plus 1.5 square.
2.5, sir.
So this distance is 2.5 meters. This distance is 2.5 meters. This is sigma fx is equal to 0 minus fcd minus fbc cos 53.13 is equal to 0. Sigma fy equal to 0 plus fbc sin 53.13. So here after that we are calculating the free body diagram H B. Those who are unable to solve it, please see this. Now this is sigma fx is equal to 0 minus FAB minus FBC cos 53.13 equal to 0. So what is the value of FAB? FAB is 22.5 kilonewtons tension. Now sigma Fy equal to 0 plus 10 minus FBD minus FBC sine 53.13 equal to 0. We get FBD value, which is minus 20 kilonewtons. After getting this FBD at D is to be taken. This is force in BD, force in AD, force in AE, sorry, force in DE. And here force in CD. This angle is 53.13. So sigma Fx is equal to 0 once again. Minus FDE minus FAD cos 53.13 plus FCD equal to 0. Sigma Fy equal to 0 plus FBD plus FAD sine 53.13 equal to 0. So you will get the value of FAD. FAD is plus 25 kilonewtons. Thank you. Substitute this FAD value in the above equation to get FE, which is minus 37.5 kilonewtons. So after getting these values, prepare the tablet form, serial number, length, force, it is in terms of kilonewtons, then P square L by 2. So first member, AB of length 1.5 meters, the force in AB 22.5, that is plus 22.5. Second one is AD, which is 2.5 meters. Third one, EC of length 2.5 meters. The force in BC 37.5 kilonewtons. It's plus 37. Fourth one is BD, which is 2 meters. And force in BD is minus 20. Fifth one, CD. So this is CD is 1.5 meters. Force in CD minus 22.5. One is E is 1.5 meters minus 37. So do this calculation here. This is P 22.5 whole square into. Now understand here, this unit is in kilonewtons. Length is in meters. 0.5 by 2 into. Just to see the question, area of the cross section is mentioned as. What is the area of the cross section given in the problem? 1500 square
100 mm square.
mm. Oi, 1500. 1500 na?
Yes, sir. 1500 square mm.
Yes. So we have to substitute in terms of meters. Why? Because all the units are in terms of meters only. So 1500 mm square by 10 power 6. You will get the units in terms of meters, which is 1500 into 10 power minus 6. That is the area of the cross section. E is given as 200 GPa. 200 GPa. MPa. You have to convert in terms of MPa into 10 cube MPa, or 2 into 10 power 5 Newton per mm square. But here see, 2 into 10 power 5 by 10 cube, you will get in terms of kilonewton. While mm square is there, so to get in meter square, you multiply with 10 power 6 to get in terms of so this is how we will convert the units from Newton per mm square to kilonewton per meter square. So you will get it as 2 into 10 power 8 kilonewton per meter square. What is this value? Two point five by 2 into 1500 into 10 power minus 6 into 2 into 10 power 8. Similarly, the remaining things should also be calculated. So you will get the P square L by 2 AE values. All of you tell me one thing. What is for final value? Sigma P square L by 2 AE. All of you, are you able to follow it? Twenty-six, roll number 20 series. Series 133. What is the value? If you get this U value, then deflection delta is nothing but 2 2u by w or 2u by p. P or w both are the same here. So in that way, now the units will be, all the units will be converted in terms of kilonewtons and meters. So the final unit will be in meters only. Can I get the response from you people? Final value, is it Vishnu? Is it delta value or U value?
U value, sir.
U is 0.015.
Yes, sir.
2 into 0.015 by W. W, what is the value here? W? 30. So that is the deflection FC out of this problem. Find the vertical deflection of the joint D for the truss loaded. All members have the same sectional area. Draw this diagram. So this angle is 45 degrees here. This is 45 degrees. And this is 90. Here this is 90. All the joints here, they are pinned joints. So here this is 90 degrees. This is 90 degrees. A, B, C, D, E, F, G, as well as this is cross-sectional area is the same, but the lengths are not the same. Lengths are not the same. This is here. This is 90 degrees here. This is 90. This is also 90. So if this is L here, this is also between L. This is also between L. This is also between L. Now this is L. This is also L only. And this is also L. This is also L here. This is also L here. Length is the same. Here, this is also L. This point is also L. Whereas this is hypotenuse. So square root of L square plus L square. That is nothing but root 2. This is also root 2 L. These are the lengths of the members. Now, what they are asking, the vertical deflection at a joint D is to be calculated. The vertical deflection at a joint D is to be calculated. So for this one, we know that to get the vertical deflection as per strain energy method, we have delta is equal to 2U by, here instead of W, it is P. Point where P is acting. So we have to write down it as, or you can write down this also W also. No worries about that one. Now, here U is nothing but sigma P square L by E. So P is nothing but what is the force in the individual members. Now go joint by joint, and after doing joint by joint, get it, you draw the free body diagram, and at each free body diagram resolve the forces and calculate what is the force in the individual members. After getting that, and the length of the member also is known, prepare a tabular form. So from that get what is the total strain energy. After getting total strain energy, you will simply get this one. Deflection at D is nothing but 2U by P. So you practice this one and tell me what is the answer. What is the final answer? Practice it and let me know whether you are able to solve it or not. Is it fine? So can you solve? Can you people solve it? So here the difficulty is nothing but resolving the forces. You have to resolve the force along x-axis as well as along y-axis and get the forces in each number. I hope you people will calculate this one and we'll move to the next method. Practice it, same in the answer. I'm giving you the answer. Here the deflection at a D is nothing but upon simplification. Upon simplification, the value is 2 into 4 plus 2. Or you can write down that as 1.414, that is 2 into 5.414. Whatever may be, the answer is this is the one. Delta D is 2 into 4 plus 2 into PL by 8. Please have a look on this and try to get the answer. Note down this question. If this is completed, we'll move to the next one. Please let me know whether you have noted down this question or not. asking you whether you have noted on it or not. If that is done, we'll move to the next one. Okay, right. So you practice it. Please leave some space and practice it. Practice it, and we'll move to the next problem. Another practice problem. Go to the next problem. Find the vertical deflection of A of the structure shown in figure. All members have the same cross-sectional area. So this is the diagram given. This is making an angle of 60 degrees here. This is making 60 degrees here. This is support C, support D. This is B. This is A. Here a vertical load of capital B is acting. So he is asked to calculate all the members have the same cross-section area as well as the material Young's modulus is E only. Now calculate what is the force in each member AB, BC, CD, BD as well as AD, and get the deflection at A. So to get the deflection at A, you will calculate this one as so from this, after getting all the forces sigma E, there is sigma E squared L by 2 AE, which is the strain energy. From this, you will get the answer. So note on this one and leave some space. I am giving you the answer. Please check whether you are able to get it or not. So here, using your pressure of joints, first of all, calculate the reactions at C as well as reactions at D. After getting reactions and C and D, you go for each joint by joint. So where you have to take the free body diagram, wherever the number of unknowns are less than or equal to 2. If this is 60, this will also become 60. So considering this, and this will become 30. So considering this, you first take free body diagram at A, then B, and C. The entire forces can be determined. So after getting that, you go for the total strain energy, which is sigma 2 square L by 2 AE. Here, length of the members. Yes, the length of the members are to be given. This value is L. Only the value of this one is given. If this is L, you can also see this is also L. Can any one of you tell me what is the value of BC as well as BD? So this is 60. You take tan 60 is nothing but BD by C. So BD is nothing but CD is nothing but L. Tan 60 is root 3. So root 3 and L root 3. This is BD value. Let us coming to BC. Take cos 60. Cos 60 is CD by BC. We require the value of BC. So So BC is equal to CD by cos 60. CD is L. L by cos 60. Cos 60 is 1 by 2. So which is 2L. So BC is 2L. This is 2L. This is also 2L. Okay. So using this, get the forces. Calculate U value and substitute here to get deflection at A. The final answer is, please check whether you are getting the same answer or not after doing this problem. So root 3 is 1.732. So that is nothing but 7.732 PL by AE. The value will be, final value will be 7.732 by AE into PL, or PL by AE into 7.732. So these problems, make it as an exercise and do it by yourself. Let me know whether you are getting the answers or not. In the next class, I will ask you how many of you have completed these two problems. If if you people have noted down these two problems, we'll move to the next concept.